Lesson 9 is multiplying matrices, and this is a long lesson. Matrix A can be multiplied by a matrix B if and only if the number of columns in matrix A match the number of rows in matrix B. So a matrix A can be multiplied by another matrix, we'll call it B, if and only if the number of columns in A match or equal the number of rows in matrix B. So we're going to just kind of look at, can you multiply these matrices? So if A is a 2 by 4, now remember, we name these by rows, by columns. So in A, the number of rows is 2, the number of columns is 4. And B, a 4 by 2. So we have to look at the number of columns in A, so the 4, does it match the number of rows in B? And rows would be 4. Yes, they match. So yes, we can multiply these two together, and what's cool is the result will be a 2 by 2. And we get those numbers from the original, the row in A and the column in B. How about these two? A is a 3 by 2 and B is a 3 by 2. So we take the number of columns in A, does that equal the number of rows in B? No, we cannot multiply these two. How about these two, a 3 by 2 and a 2 by 5? The number of columns in A matches the number of rows in B, so yes. And the result will be, or the answer of the multiplication problem will be a 3 by 5, and you get those numbers right here. So let's say we were multiplying A, we're going to do a 2 by 2, and we're going to use letters, and I will show you an example with numbers, so don't freak out yet. And we're going to multiply it by matrix B, and we're going to make this a 2 by 3. That way the rows will will match the number of columns in A. So we have 2 columns in A, 2 rows in B. We will be able to multiply these. And you can even look at this and say, okay, A is a 2 by 2 and B is a 2 by 3. So yes, we can, and the product will be a 2 by 3. So if we multiply those, A times B, we're going to get a 2 by 3. So we're going to have 2 rows and 3 columns. So in column 1, row 1, you take A times E and you add B times H. You add B times H. And that sum will be the number that goes in this spot. The first row, second column. So we take our first row, A and B, and multiply it by F and I and add them together. So we have AF plus BI, and then the first row, third column is A times G plus B times H. Second row, first column, we do C times E plus D times H. Second row, second column, we do C times F plus D times I. Second row, third column, C times G plus D times, that should not be an H. This should be a J, so D times J. And we take the sum of each of those products, and that will be our numbers. So here's an example. We're going to do a 1 by 4 times a 4 by 1. So our answer is going to be a 1 by 1. These two will match. So we're going to take our 1 by 4. That means 1 row, 4 columns. We have negative 3, 2, 6, 4 times, and we're going to do a 4 by 1. And that means there's 1 column with 4 in it. So 5, 0, negative 1, 3. we're going to get a 1 by 1, which means just one number as an answer. So to do this, I'm going to take -3 times 5 and add 2 times 0 and add 6 times -1 and then add 4 times 3. And I get -9. So it's a matrix with one element, -9. In a matrix, we have what's called a main diagonal that goes from the top right down to the bottom, no, the top left down to the bottom right. So I'll circle the main diagonal in this example. So AEI, this diagonal right here, we call this the main diagonal of any matrix. Just goes from the top left down to the bottom right. So we have what's called the identity matrix. This is the multiplicative identity matrix. Again, just say multiplicative because it's just so much fun to say. Multiplicative. Oh, I love that word. Multiplicative identity matrix. We sometimes call it capital I. And that's just the main diagonal are all ones, so the number 1, and every other element is a 0. So a 3 by 3 identity matrix is just where, remember, the main diagonal is all ones. So anytime you multiply by the identity matrix, you're going to get what you started with. So if we have a 1 by 3 times a 3 by 3, we can multiply those because the number of columns equals the number of rows in the second one. So here's our 1 by 3 times, and we're going to do the 3 by 3 identity matrix. And anytime you multiply by the identity matrix, as long as you can do the multiplication, the number of columns matches the number of rows, it just equals the original matrix. 0, 1, 2. So sometimes you can say any matrix times the identity matrix is going to give you that matrix back. You'll see that sometimes. Okay, that's the end of lesson 9.